You're live, right?
Not yet. Right now I'm seeing the stream on YouTube to go live.
You're live. We are live, I think.
Yeah, yeah. Hello everyone. I am Harshit Yadav, third year ASF representative from Triple IT Gwalior. In various projects, developers often have to deal with various features offered by third-party vendors in the form of APIs. These APIs often provide convenient ways to add complex features to your application and take it to the next level with minimal developer effort. Because of their simplicity, it is just as simple as plug and play to set them up. But with online traffic growing by the day, websites need to scale to serve millions of users concurrently. So, how do we make sure that these third party APIs scale as well? So, with HackStack, we are here with our speaker session with Alpesh Vaz, lead SWE at Headout, to help you explore this domain. Before we begin with the session, Alpesh, could you please tell us more about yourself and share your experiences?
Yeah, sure. Hey everyone, I'm currently backend lead at Headout, and I've been working at Headout for around 4 years now. In the past 4 years, I've led different verticals at Headout like payment, fulfillment, inventory and pricing, integrations, and I'm currently leading this pod called Supply. So we are currently building a hub where like any supplier or let's say any new vendor can join us, and they can start listing the attraction tools, etc. And like also any existing vendors who are partner with us, they can manage the inventory, they can manage the pricing and all. So before this hub, we used to happen. This used to happen internally and by our own team, and like our operation team used to manage all these things like listing and attraction tools and etc. And like we were kind of like wasting resources internally, which can be delegated to like suppliers themselves. So by delegating this task to like suppliers, we'll be able to like scale our supply and our number of vendors at much faster rate than earlier. So more supply means like more growth, and like hence like will this will enable us to like increase our business revenue. So yeah, that's about myself and my current role at Headout. Yeah, so I can start with the presentation, right?
Yeah, all right, then let's begin with the session.
Hello, I think we lost you.
Hello.
Cool.
Yes, we can begin with the session, Ritesh.
Yeah, cool. I'll share my screen. Just a
Yeah,
moment.
sure.
Screen visible. Hello.
Yes, it's visible.
Yeah, it's visible.
Cool.
Yeah.
Cool. Uh, so okay. So main topics of like today's topic is like how we handle third-party APIs at scale with plugin architecture. So like I'll break down the topic into multiple parts and I'll go through each of them one by one. So I'll start with the basic one, like what is API? I mean, you might already know like what is API. It stands for Application Programming Interface. Uh, in simple terms, it's just an interface to an underlying like complex implementation. And implementation can be anything complex, like you can say like naming and directory services like LDAP, DNS, which implements JNDI API. JNDI stands for Java Naming and Directory Interface. And few more I can tell, it's like Hibernate. You might have also heard about Hibernate. It's like uh, Hibernate also implement this interface called JPI, Java Persistent API. And few more example, let's say any backend microservices like order, email, catalog, whose functionalities are also exposed through like REST APIs. So these are all the example of API. API doesn't necessarily need to mean like REST and SOAP APIs. They can be basically any interface which hides underlying complex implementation, like hides intricacy of the system and provide like very simple interface to connect with the system. So that's about API. So like use case API at Headout. So like whenever at Headout, like whenever we partner with let's say any supplier or vendor, they provide us a way to interact with the system. Now, let's say if vendor is, let's say, tech savvy and let's say has a good engineering team, then he might have developed their own API. Let's say if supplier doesn't have enough resources to develop an API, they use this third-party API providers, which are also called as RMS, which stands for Reservation Management System. So here I listed like few, like Resdi, Bokum, like some of them are like RMSs, and so in the end, but in the end, like we, whenever let's say we partner with any supplier, let's say any vendor, we get an API which we can use to talk to the system, and we use that API for multiple purposes. Let's say registering booking to supplier system, getting tickets for, let's say, redemption, and also, let's say, fetching availability for the different attractions. Like some attractions might have, let's say, limited availability, and they might have, let's say, only 50 slot, let's say 50 packs per, let's say, per hour. So we basically fetch their availability for different attractions. And currently, it had out around 92% of bookings are automated, like through API and other means of automated like methods. And like customer gets tickets in a matter of seconds. Okay, so that's about like how we use API head out. Like if I talk, hello.
Yeah, you're audible. Rupesh.
Yeah, I think it's got the message. Cool. Uh, so if I, sorry, my bad. Yeah, if I talk about like challenges, so there are like few multiple challenges, like some are technical challenges and some are non-technical challenges. So if I talk about like technical challenges now, like based on how technically advanced any supplier or let's say API provider, API can be of diverse nature. Like there can be different protocols they might have used. Some, for example, like SOAP, REST. You might have heard about REST and might be like SOAP, but like SOAP API is like very SOAP is like very legacy way to expose your features through API, and it only accepts and serves XML. It has very like restriction and all. And then it comes the REST, which doesn't impose any limitations on data transfer. It can be, let's say, JSON or XML. It's kind of like modern way of transferring state. And it's right now it's like industry standard for all like modern applications. Like people nowadays use like REST only for API basically. And other technical challenges if I talk about, like there are like slow legacy API, like it depends on like how like legacy like supply system is. Let's say if they are very old, then they can have very like so many issues, like the API might be very slow, and there are other issues like rate limits in modern APIs, and like your like underlying implementation is software component only, right? And like software component can fail, so there are API failures also, like API can go down also. So we need to make sure that like we handle all these challenges, all these, let's say, faults, and like we make our system fault tolerant, and we need to make sure that like this doesn't affect our like customer experience basically. So these are technical challenges. If I talk about non-technical challenges, like since we are like travel provider like OTA, so we have a diverse set of attractions, right? Like there are theaters, there are museums, there are walking tour guides, there are helicopter rides, there are like safari rides. So these are like diverse set of attractions, and there are also like different type of details required based on like nature of the booking. Like because like supplier might ask height, weight of let's say customers, age of customers for different reason, passport details, and etc. So these are some non-technical. Like one more I can talk about is like mapping of, let's say, mapping of headout object models with supplies model. For example, headout might represent booking as a like separate structured way, and like supplier might also like represent it in a different way. For one example, let's say we like represent like tax type, for example, adult, child, etc. as like enum, and supplier might have a different way of representing it, like they might be representing as like ID, integer ID. So we need to figure out a way to, let's say, map headout models with like supplies model. So these are some non-technical challenges. So like as I like talked about like technical and non-technical challenges, like how do we solve it basically? Like there are so many various set of like requirements, right? So we need a way to standardize all these various set of requirements so that any new APIs can be added seamlessly and they can adopt all this standardization. Uh, so uh, yeah, so basically we use plugin architecture. Uh, so in plugin architecture, we basically encapsulate and standardize all these requirements. and these requirements are encoded as like plugin standard. And yeah, so let me explain. This is a there is some diagram also, basic plugin architecture. There are like few components like plugin standard, and core system. So I'll let me go through each of them and I'll explain those in like detail. Okay. So for plugin standard, here in plugin standard, basically we define like a set of standards or interfaces, and each plugin need to adhere to those standards, API, those standards, and implement those interfaces. And API is not only like API is not only about REST API. As I told before, it stands for any set of interfaces where you define like basically standards and contracts. So that's like plugin standard. Then comes the plugin. So plugin is nothing. They just implement the standards defined in plugin standards. And in software terminology, they are like interfaces, and these plugins implement those interfaces. And yeah, so those are plugins. And like this here is like very like slightly complex architecture diagram than the previous one. Here you can see there are like multiple services, and there are like few plugins. The plugins can be shared across different services. And to, let's say, shared across different services, there are things for plugin manager. Plugin manager is nothing. It's like just a like software component which maps plugin name with its palettes, and palette is just a like instance of a plugin. Yeah. So these are plugin manager, explain plugin standard. Yeah. So these are basically like our architecture overview of like this plugin event, like plugin architecture and all the components. So like how we add it to our system basically. So let me just go through it once more. License systems or services who want to use this plugin, they only know about this plugin standard interface, and all the implementation detail is like hidden to them. Like same as API, basically we hide complexity of underlying system, and they only know about these interfaces, and we talk through interfaces. Basically, yeah. So plugins are added to other system like plugin manager, and yeah. So so some example, like headout example, if I talk about, these are few interfaces that I like take from our usage. So these are some plugin interfaces. Like we also call it like head-on common API, and API contracts. These are the API contract that every plugin need to implement. So here are the few. The book is one of them. Cancel is one of them. This T represent generic, since like every plugin has like different kind of nature, and they might have different way of representing data models. So we use generic to solve that problem. And yeah, so this is for booking, so inventory. And since like we need a way to like standardize all the models, right? So these are some models that I can like like share. Like I went to vendor booking, where there's like booking ID, there's booking date, booking time, and there is guest name. And in the booking response, we get like order ID from supplier, and we also get like booking amount, pickup hotel, pickup location, etc. So these are all like interfaces, and all these interfaces need to be implemented by uh, like underlying plugin. So yeah, let me show one example for plugin also. So this is one of the example for plugin, like template plugin, where it has implemented this book method. It has implemented this iVendor plugin and booking and inventory plugin basically, and it has this template code. So this is like one of the example. You basically, let's say, transform our model, iVendor booking model, to a customer like suppliers model. Basically, this is the suppliers model, create complete reservation. And once we, let's say, transform headout model to like suppliers model, we basically call this API. So this is plugin. This is one of the example. This is for plugin manager. So as I told, in plugin manager, it just stores instance of plugin, its plugins. It's like palettes, and they have only like they have a map. So in the map, there's like name of the plugin and instance of that plugin. So this is plugin manager. Uh, yeah. So now, like let's have defined plugin standards, plugin interfaces, plugin manager, and plugin concept. So like how new plugins are created and added to new APIs. Like let's say whenever we get any new API to integrate, how do we like proceed forward. So we have currently like multiple different GitHub repository for different purpose. Plugin standards, basically all the plugin APIs, common interfaces are stored in different GitHub repositories called headout common APIs. And then we have different GitHub template repository, basically, which we made public around like 6 months back. And this template repo is depending on headout common APIs and to access all the standards, all the interfaces, etc. And so now that we have GitHub template repository, like what we do is we basically create a private GitHub repository using this template repo for every new APIs. And once implementation done and tested, we add them to our rest of the system. So let's say once we have created plugin, now this plugin can be added to any system basically. You can add to like service A, or you can add to service B, or you can add to any service basically, and you can also choose and remove those plugins and plugin using plugin manager. So, and you can also basically, let's say if you want to create a mock plugin to, let's say, to test your flow of plugin manager, you can also, like, since the standards are defined, interfaces are defined, what you need to do is you just need to implement like mock plugin, and you can just plug that mock plugin to via plugin manager. And this way you can also like test different flow of your system. So like this plugin, basically plugin architecture comes with like lots of flexibility. You can do anything. You just need to implement those interfaces. And this all the other services I only know about your standards, all interfaces only, and they don't know about underlying implementations. So yeah, that's how we add a new plugin. And now that we have a different GitHub repository, right? So like how inter repository dependencies handle, and like since our most of the projects are in JVM based, so what we use basically Gradle for dependency management for like all the projects. And Gradle is like you might all like already know about Gradle. Gradle is like general purpose build tool used mainly for JVM based projects. And since we have like in Hadoop, like we have multiple private repository, right, with multiple plugin implementation. Like we need a secure way to publish. Let's say whenever we create a plugin, we need a secure way to publish artifacts privately, right? Those need to be like visible only to head out organization. And artifacts, yeah, artifacts are nothing but like bunch of jar files, which has compiled classes so that you can add those as a Gradle dependency, like wherever you want. And you can also call this like private libraries. So now like to store artifacts, like we need to store artifacts like privately, right? So that they need to be visible only through like headout repositories, all headout private repositories. And to now store a repository, there are multiple solutions. You can basically maybe create a jar file and add it in your code base, but like too much manual overhead is needed here. And what other thing you can do is you can use like third party solutions like Bintry, Maven private repository, uh, etc. Like Maven private, like there are a few more also, but those are quite like costly. Like let's say Bintry is like $150 per month, and which is like too much, right? uh, so yeah, GitHub packages. I like third is GitHub packages. Like GitHub has introduced these GitHub packages very recently, and like they are free for, let's say, if you have just 2 GB, you can share. Let's say if you're using only 2 GB data, 2 GB of artifacts per month, then it's like completely free. And let's say even if your usage goes beyond that, they're like 0.25 per GB, $0.25 per GB post that, which is like very cheap, right? And there are other interesting solutions also, like the interesting way to solve this also. Like you can store them in like your self-hosted S3 buckets, and whenever let's say any application need to or like add those artifacts, they can just add a dependency to, like they can add in like Gradle new repository, and that's repository will implement S3 buckets, Gradle Maven thing. And you can use like, yeah, this basically S3 buckets also. uh, so there are like I have written like separate blog for this. I will share it separately. So there are some interesting solutions to achieve this, but we use like GitHub packages right now. uh, so yeah, GitHub packages are like very uh, using like it's like very close to your code base, right? Like you are using GitHub for to store like it's for your code. So like GitHub packages are very stays very close to your like code base. So yeah. So that's about how we store and publish artifacts. Uh, so like now that we have different repositories, right? So we need like some kind of tooling to like make shipping faster. Like we have separate repo for templates, separate repo for each plugins. So we can't be doing this manually. Like whenever let's say someone creates a plugin, we can't just like add like go take the repo, like clone the repo and like uh, get artifacts and like store it manually. So we need like some tooling to like do this automatically, right? So we use different like GitHub services like GitHub Pamphlets I already mentioned to quickly create a skeleton repo for any new API integrations. Uh, then there's GitHub Packages. So in GitHub Packages is also GitHub Packages way to hosting. Basically, GitHub Packages is a platform inside a GitHub ecosystem for hosting and managing packages, including containers and other dependencies. And your packages are as a tool. Your packages stays closer to your GitHub repositories. Then GitHub Actions, like we use GitHub Actions to automate all our like software workflows, perform you can CI/CD operations. So how we basically so let's say now that you have a like separate repo for each plugin, so how we automate package creation and publishing. So we have written multiple workflows internally, which runs on event like release event. So whenever which will create which will basically create builds and run builds and which will create artifacts and publish it to GitHub packages using GitHub Actions. Whenever let's say you make a change and let's say you create a release, and this workflow is automatically triggered on like whenever you create a release. And these published artifacts are can now like let's say now your artifacts are automatically published to GitHub packages. And now so whenever you publish your GitHub package, you get a link, you basically get a like unique identifier for that package. And in your code base you'll have to basically mention that URL of that GitHub package repository. And you will be able to use those packages like to any repo basically. Yeah. So, and this setup need to be done like once only, right? Let's say that link of repository is fixed. So once you, let's say you create a new service, and let's say if you want to use your plugins there, so what you need to do is you just need to basically add that link, that URL of GitHub package repository as like on that Gradle repository URL. And that's done, right? Then that's a one-time thing. So whenever let's say there is a change, you need to just change the version. Let's say we upgraded version to let's say 1.1 to 1.2. You just need to change the version in your like all the services to 1.2, and you will be able to get all the changes. So yeah, basically we use like this tooling to like ship faster. Yeah. Okay. So for local development, like you might have heard about Maven Local, but you might not have heard. So we use Maven Local, which like so same way like GitHub package has a repository in like remote URL, like remote server. So same way in the Maven local, what happens is which we create, like it creates a local repository. And your local repository basically it uses your local file system like to store artifacts during development. So let's say while developing in your local system, what you do is you just make a change, you like build your like build your artifacts, and you just publish it to your Maven local. And let's say there's one more service in your local system, and what you do is you change the URL to your. You can basically maybe do this using like environment variables, right? So like, you don't need to change the URL every time. And so in your, let's say in your other service, you just need to like refresh your Gradle and like rebuild the Gradle packages, and it will basically just fetch those artifacts locally from your local file system. So that's how we do like local development. And finally, in the like since we are using a plugin system, right? And everything is like decoupled. Plugin doesn't know about other system, and like other system doesn't know about plugin, they just know about interfaces, right? So we also need to know like how those API integrations are performing, how those different plugin are performing. And like as I told in the beginning, like there are errors, right? There can be rate limits, there can be API downtime, and all kind of things. So we need to also store metrics so that we whenever there is any downtime in any API, or let's say there are so like failure is, let's say if failure rate increases, then we need the way to know what plugin is failing and what plugin is like performing well. So there are also like severity of errors, and alerting is like very important when you are, let's say you have, let's say around 30-40 of plugins, and you can't be doing checking all this plugin manually, right? You need some way to like alert your system that plugin is going down, or let's say the particular API is not performing well and there are so many errors and that kind of thing. So alerting is so that we can quickly get to know about those errors and fix those. So since like all the plugins are like decoupled from other system, implementation can be tricky. Of like implementing a matrix can be tricky, right? Let's say if you want to like there are multiple ways to like publish and let's say like push your metrics to like let's say particular different data. So the different way to like store them, like the Grafana is there, this big data, and there are a few more also. But let's say you can't be, let's say, adding this dependency Grafana big data dependency to your plugin, because there are around, let's say, 30 plugins. You can't add those dependency to like 30-40 plugins. So how we implemented was like we basically abstracted the implementation, and all the plugins doesn't know about which data store we are using. It's the same as like how we define API interfaces or API contracts. So in each plug like this, in the beginning I mentioned this plugin, right? Yeah. So in this event plugin, there's one more method called event tracker. So basically, whenever any service want to use any plugin, they basically just pass the event tracker. And event tracker can be anything. They can be a big data, let's say Grafana or anything. And they just pass the event tracker. And whenever, let's say there's an error, plugin will record the error and just push the data to the data store. And so there are different like Grafana and big data, right? So big data is also like analytics. Let's say if you want to understand your how particular API is performing on a, let's say, daily basis, so we can create the dashboards on top of it, and we can see daily, let's say daily error rates, daily failures, and etc. And whenever you can set alerts, you can set thresholds, and based on threshold, you can set alerts so that whenever particular API goes, but error rate for particular API goes beyond that rate, you can just like alert the system, and you can basically fix those errors. And yeah, instead of like customer can come back to and tell that particular is coming, like this matrix can help you understand and identify the issues way earlier than later. So it's like proactive way to get the alerts. So yeah, that so we basically abstracted the implementation so that plugins are unaware of the underlying store. And let's say whenever we add a new plugin, they just define the interface, and like it doesn't need to do anything else. All the services who consume that plugin, they'll just pass the data store, and everything will work as it is. So that's how we implemented metrics. Uh, yeah, I think yeah, that's pretty much it. So thanks for your time. I think I have covered most of the topics. And if you want to discuss, let's say any of the topic, or let's say want to know more about this plugin architecture, you can reach out to me on like Twitter. You can like just add out Twitter account also. Yeah.
Thank you, Alpesh, for such an intellectual session. We really appreciate your
Thanks.
insight and time. I'm sure, yeah, I'm
Mhm.
sure your session would have given students an insight into how large companies like Headout, which needs to operate at
Mhm.
scale, use modular-based architecture. I would like to thank our audience as well for watching the session. With this, we would be concluding the session. Thank you, Alpesh. Thank you.
All right. Thanks for your time, people. Yeah, thanks and all the best for all the participants for the hackathon. I hope the session was great and insightful. Yeah, cool. See you.
All
Bye.
right. Thank you, Alpesh. Thank you very much.